what is Apollo Federation and what does it has to do with schema stitching? You might heard of schema stitching maybe, or maybe of course only from Apollo Federation. So basically, as you saw before, GraphQL is a very graph-based and edge-based technology. So basically, you could stitch things together, right? So think of it, if there is a subgraph, like you have a user, for example, and it has some items in it, you can immediately add things to it on its way. So I'll show you one simple thing. So for example, if you have multiple queries, this is the Apollo GraphQL Sandbox Explorer. For example, I prepared the me endpoint. So it's just a normal user. And we can fetch the ID and the name. So if we run the query now, we just see the data which is exposed. Also, if we have reviews inside with an ID and an offer, or let's remove the offer from here, just show the ID to make it less verbose. We just see the data. We don't know where it comes from, right? So basically, the reviews with Apollo Federation or schema stitching could come from somewhere else. Because maybe it makes sense that reviews should come from another endpoint, from another maybe REST API where you fetch the data from, or something else. So I can show you how Apollo Federation is solving these kind of things. So basically, you can think of it as a gateway where there's one endpoint for all of them. In our case, I just used the Apollo Federation demo from the GitHub repo. So there's the accounts, reviews, and products in it. So basically, when I go into the accounts, we can see that there is an extend type query. So it's kind of different because usually you have a type query where you just define some new endpoints and there's maybe some user and it returns a normal user. But this is different because we just extend the query, which means the gateway, which is the central point of all the addresses, just extends the query with the type me. And the accounts endpoint also has the type user. It's when you don't have an extend before, it just defines the type user. What you can see here that if we go back to our Explorer and we go to the type me, you can see that it returns the type user, and inside the type user there's also the reviews. But in the code, you see that in the normal type definition, there's actually no reviews in here, right? So where does it actually come from? And why does it matter? So actually, we have the accounts, and there's actually also the reviews endpoint in here. This is just a monorepo, but separated into each and every own Express server. So on the bottom, each and every file has its own server, which is listening on a different port. So for example, in the reviews endpoint, we can see that there's another extend type user, right? So we just extend the normal type and extend it with the reviews endpoint. But how does it work? So in the accounts, we can see with the type user, we can see that there is another thing, which is usually not in the GraphQL spec. There is the add key with a field's ID. This symbolizes GraphQL or Apollo, that this key can be used as a primary key to extend it for other services. So for example, the reviews is the other service who just extends the user with the key of ID, with the key ID. And also inside of the query, we can say that the ID is external and can also use different and other queries which are now external, which can be used later, which I show you. So how does it work? How can we now say, now we just extended everything, the schema and everything, but the data is not yet really here. So as already Luca said, there are some resolvers where you can get the data from, where you can do whatever you want, where you can get the data from. We extend actually the user type, which you can see here, right? And in here, we see also the reviews endpoint. And in here, you can do some async work. We can async some data query or fetch or do some data in here. It doesn't matter. The only thing which matters is that we have something in return. In this case, we get the user inside, and and everything which gets in here is now from the keys. So that as you can see, the user is now exposed user.id, and as we also have another external, we can also say user.username in this case. So this is actually a pretty nice technique that we can now stitch things together. Maybe you heard about schema stitching. It's kind of the same thing, the same principle, but schema stitching works on another level. In this case, we kind of stitch together those endpoints on service level. So each and every node server has its own technique to stitch things together. But in schema stitching, everything is on the gateway level. So the central point where we say where data comes from. And in here, there's a stitching technique and stitching endpoints that you do it manually. There's a left join, right join, and whatnot. There are also a lot of tools where they can help you. But Apollo Federation actually helps you on the first place where you just define the type in it. Also, a quick tip, CodeGen also supports Federation. You just type in Federation to true, and then you get all the nice tools which Lucas just showed you before. So as we can see now, when I go back to my Apollo Explorer, we can see that the reviews part is now coming from an external service, right? So this is actually the good thing. Also, a very good thing is that you have the type name just built in, so you can use GraphCDN out of the box, and we can relieve our gateway with some cached data, right? So everything is out of the box. Everything is now still with GraphQL. But you can make even more stuff. For example, in this case, we only have the reviews with another kind of object inside, right? But we can make it even further. So there is actually another query you can see. There's not just the me user, but also the top products. The top products is just a list of products. So when I just fetch the name, we can see there are 3 different products: the table, couch, and chair. And there's if the product table, couch, chair is in stock. You can see again, it's just a normal query, but behind the scenes, maybe something is going differently. So let's look in the code. So for example, the products. In here, we just say, okay, we extend the query with the top products. Everything is fine. We just extend the query for the gateway and define our normal product. But it's weird because we just see the UPC, which is the kind of ID here, the name, price, and weight. There is nothing in here with in stock. So where does it actually come from? All right. Apollo Federation got it covered by having the key, so you can extend everything from another service. And we have the inventory service, our Node.js service. So we go into there, and we can see that there is another extend type. So you can't just extend queries. You can also extend normal types of, in this case, product. As I discussed before with you, there's another add key where it just says where it comes from. So in this case, we symbolize that there's the UPC, the kind of ID from this product, which is required, of course, and it is marked as external. So it comes from the original type, which we have defined in the products service. And in here, we can find the in-stock Boolean. So this is what we just saw before in the Apollo Explorer. And I will come to the shipping estimation right after it. So how can we now stitch together those 2 products into one kind of API? So we can see there's from Apollo Federation an own object or an own function called resolve reference. And please mention the underline in before. It just symbolizes for Apollo Federation that this one should be used for stitching those things together. So what it does is in the object, there's coming all the fields which I just discovered, which I just marked here as external. So I can use in the object, or I can also write it as product, right? So the product has now the UPC, the weight, and price in it. But for my reference and for my stitching technique, I just care about the unique ID, because the inventory, which I just defined above here, just has the UPC ID and some in-stock true false. This can come from an external API or somewhere. In this case, it's just a local thing. And beneath, under this, the normal product comes in, which I just fetched. Plus, I just make a comparison here. I just look into my inventory field and find the current product. So, in the product, I loop over it, and I can see, okay, is the product UPC the same as the object product object UPC? And then I just return it. So now I just made the first stitching here. So the in stock comes now from the stitched together thing from Apollo Federation. This is actually a great thing if you have a lot of services and a lot of separated node services around somewhere. Yeah. So you can go even further actually. So as you saw, there's also the shipping estimation or shipping estimate as key. So I can define it as int, and there's another thing where it's called requires. So what does it mean? So Apollo Federation goes over it and say, okay, there's the field, and it only can exist when there's the field price and weight. So when you have a new field, you just make a space and type in UPC, which is great. And after having the shipping estimation, you get again the object, so everything which is now in here, which is now defined, and you can go over the price, which you just got from the product itself, and the weight, which you just got from the product itself. So if you don't have that, and if you want to have that, you need those fields, and those are required. And voila, if I go back to my Explorer, I can go shipping estimate, run this query, and then I can see, in this case, some fake data. But in the end user don't know where these things comes from. And this is very important for a microservice architecture where you don't know where things come from, but you're just interested in the things that something is coming back. So the right things, right? This is actually very interesting to see. Again, as you could see, there is the server listen. So you can just spin everything up. First, you need the services, and then the gateway, which is again the central place of all the things. There is the Apollo gateway package, and also the class in here where you just define everything. And of course, the Apollo server, where in this case subscriptions are not supported for now, so they are now disabled. And also, you have the gateway in here, where you just define the gateway. You might think of Schema like Apollo Federation said that it's kind of this, or actually the same, and it's a replacement of Schema Stitching, but it's not entirely true. There's one case where this is not the case. Basically, you can, in Schema Stitching, you do everything on your own or use tools, of course. But there's actually one thing when you have an external graph from somewhere, could be, I don't know, a demo graph. You can't actually attach it to your Apollo service because it has, as you saw before, the specific type declaration here that you extend, or actually it's better in the reviews. I'm sorry, in the accounts, where you extend the type. So if I just write type, it doesn't work anymore because Apollo Federation doesn't know that it should extend it. So the extend is actually pretty important in here to make everything. All right. So I prepared something to show you about something else. There is actually also, so how does it work now when I deploy everything? In this case, I use Kubernetes to deploy our things. So you can see, I don't know if you ever heard of Kubernetes. It's just a containerized orchestration service, which is also open source and founded by Google, where you just spin up, you have some Docker images and you just spin them up and they run somewhere on your Kubernetes cluster. The Kubernetes cluster is actually where your pods, or actually images, if you want to call it, live. And you can imagine that there's one pod or maybe more pods which can coexist at the same time. And there are some services in between. It acts kind of as an internal load balancer where it just redirects to your single pods and you can distribute stuff. But it's too much right now. So basically, I prepared something, some deployments. This is also a Kubernetes scheme right now. So I prepared something where you can see there's the K is just a shortcut for kubectl. Here we can see that I already deployed via Helm my all of my services. So there's the accounts service, inventory node service, products node service, reviews node service, and of course the most important part, the gateway service. So I deployed everything to my local machine, and everything can actually be used under my minikube.dev is just my local host. So I have overwritten it. And on this, there's the GraphQL endpoint, of course, where you can fetch all the data. So there's the GraphQL Apollo Explorer. When you click on it, it's the same as you saw before, with just Peer stuff. So what I actually want to show you is how you can scale your app with Kubernetes with an autoscale, with an horizontal pod autoscaler. What does it mean? So I showed you before that there are, in this case, 5 or 4 services and 1 gateway. And each and every graph comes from another service. So if I go back to my Explorer and go back to go to the reviews and see the author and get the ID. And if I enter this, we have now a deep thing where we actually have a lot of queries from the reviews, our reviews service, our account service, which is the author. And now if we have a lot of queries on it, it might scale not well because it's a lot of data on it. So basically there's a horizontal pod autoscaler, which is this case. It's basically just if you have a lot of load on it and if you don't cache anything, of course, then you get a lot of data on it. And we can say, for example, each and every pod has its own schema. So let's say when I show you the thing here, we say that accounts in this case has 100 milli-CPUs available. So everything above will just fail and restart. So let's go into K9S. It's just a little tooling where we can see all of our services with more stats in here. So we see that our deployed service, which is now local, the account service has a CPU of 11. So if I now query more, it might go up because there's a more load on it. And now I prepared something with, if I open up another terminal window, I prepared now a load test. I use artillery in here. This is just another tooling where there's a config file. I can show you the config file for real quick. The artillery config is just another YAML. I can remove that one. There's just another YAML where I execute the query top products reviews, author, and name. Like here, we define it's for 100 seconds, and 1 second is 1 request. So now we're gonna execute our load balancer, which is now executing 100 requests in 100 milliseconds, so 1 request in a second. And if we go back to the K9S, so-called, we can see it might take a while because there's the metrics server behind, which is just tracking the thing. In the meantime, I'll show you, I made a little bug in here, kinda. I have a slow function in my user reference where I just make things slower. So it's basically just a function where I compute things, which is super CPU heavy. So in the meantime, I see during my load test is running, there's an automatic container creation because my CPU went up. It's not yet updated. Maybe I have to go in again. So my CPU went to 150 in this case. And because I defined the horizontal pod autoscaler, I can show you where it's defined. We can see that it automatically scaled another pod up. And if we go back to our CDN, in this case, we got a timeout because everything is running locally and it's super CPU heavy. There's still everything running, and it's automatically autoscaled the accounts, which is actually pretty nice to have. It's not updating the CPUs in here, but if I restart everything again, it's automatic. You can see that there's the CPU load and goes back. So right after so it's already 1 minute and 31 seconds. And if I wait a little time, you can see that the timeouts went away because my Kubernetes thing automatically updated everything from the horizontal pod autoscaler. And after a while, which is soon over, so I made it for 120 seconds, which is 2 minutes. So it should complete now. In this case, I had 19 timeouts, which is the output here, the summary of artillery of our load test. And there are 101 requests, which were fine. So in total, it's 120. And after some seconds, you can see that there are 4 new pods running. So four services at the same time. And after a while, they just spin down when there is no more load on it. And it just went down. So just a really quick sample on how it looks like. The autoscaler with the new V2 beta 2, you have a new behavior field where you can define when it's scaling up and when it's scaling down. In this case, I said that there's the policy with 50%, and it gets the data every 15 seconds. So that's why it took some time. If I make it to 1 second, it fetches every time and see, okay, is the CPU to 50 already? And we also define how many pods, so how many node services there are at the same time, and just spin them up to 5. So we can control our billing, of course, because this is the most important thing. We don't want to scale up 100 services in case of, when there's a memory leak or something, the CPU also goes up, or the memory, of course. Then we don't want to spend up all the things. And also there's the scale down. So we say, okay, if there's 10% of the CPU load within a window of 0 seconds, so as soon as you get it, please don't use it in production, because usually you should wait for 5 minutes because there could be another load on it. But still, this is the way how Autoscaler works. And you're just safe after a while. So actually, which is also quite nice, which I just configured in my Kubernetes cluster, if I go back, we can see that I also introduced some kubemons in here. So from Dynatrace, which is running inside my Kubernetes cluster, which is also running locally right now. So everything right now is now monitored. So we can see the last 30 minutes. And we can see a little spike in here, which was just before here. And when we go down, we have some events where we just scaled up, or like in this case, we see that the accounts deployment has scaled up to 2. And if we go up, we also scale down there. So if we go even lower, we can see, today at 9:12, we scaled up the replicas. The replica is just how many pods or how many node services in this case run at the same time. And there is even more scaling up to 3. And right after some time, it's stopping all the accounts, services, and scale down and scale down. And we can also set some problems in here. So Dynatrace can send you a Slack notification, and we can analyze the problem if there is some. But in our case, we know, okay, it's the slow function. We can also determine it inside Dynatrace where the spike was, and we can analyze it even deeper. So to make it even more Reacty, because it's React Finland, this is the React homepage, and this is everything what I have. Thank you.
That ending was amazing.
Let's wrap up. It was a lot to. I think I have to watch it again because I never do this Kubernetes stuff. But yeah,
I loved it though. I loved it. I think Apollo Federation is super powerful. We've talked to dozens, if not hundreds, of people using GraphQL, and a lot of them are actually using Apollo Federation, particularly at the bigger size. Like when you get really big, it's a really nice way to split things between teams, and their tooling around it is really, really good. So excited to see this happening, and how well it works with Kubernetes is amazing.
Yeah, I mean, it's actually pretty nice to see how it works with different teams, right? That there are different teams that can focus on their own stuff, and you just deliver the thing what you do, right?
Yeah.
yeah.
I only knew it. Sorry.
Yes, sir. Go ahead. Yeah.
I only knew it from like the GraphQL mesh, where you can connect like multiple resources like REST APIs, GraphQL services together, stitch them together. But this, what you showed with Federation, was really powerful. So really stoked to see this somewhere in production.
Yeah, so we have a question. I think this is from Max, but you can respond and Max can respond. How many concurrent requests can be managed like this way? Because
it depends on how much money you want to spend, right? So there are a lot of load balancers which can handle a lot of things concurrently. In my case, I can't use that much because I have locally just limited resources. So I'm running my local Minikube, so my local cluster in here, which has 4 CPUs. And I only have, I think I can manage locally 2 requests per second. And that's the limit of my local machine. But of course, if you go to the cloud, you can spend there is no limit.
Fastly, just so I keep raving about Fastly, handles about, on average, I think 20 million requests every second. So a lot more than you'll hopefully need. And I don't want to know what amount of requests they handle at peak times. It must be crazy.
Yeah.
Yeah.
So this is this is actually insane how many requests you can have and how you can scale. And actually, it's pretty nice if you have a CDN, for example, that you can get those requests and just make it even faster for them, right?
Exactly. Why did you mention that? I wonder.
I don't know.
But, so because there are no more questions, maybe we can go through some takeaways from the session. So what did we learn, or what are the things to take home?
I guess
Actually,
sorry.
Go for it.
I guess don't waste time on waiting for query results. Use a CDN.
I actually think my takeaways were GraphQL CodeGen, freaking awesome. Best thing since sliced bread. Literally, if you were using GraphQL, use GraphQL CodeGen. And my other takeaway was Apollo Federation and Kubernetes play super nicely together. Use that combination as well.
Yeah, actually, it was pretty new to me. Not the CodeGen in general, but the plugin with React Query. I didn't know that one. It's like super intense what you can get, right? Because I always used React Query, of course, but I only used Query, and then in there I fetched everything. So there's the use mutation and everything, and then I just put the generic in there, which is generated, but actually the plugin is actually amazing that they have that. So this is my takeaway, of course. And of course,
I mean, the main takeaway has to be use GraphCDN. I mean, that just has to be the main takeaway.
Probably decide because of all the 3 aspects and combine all the 3 aspects at once.
Exactly. Yes.
Also, I think a big takeaway is always be prepared for a lot of users. If you have some startup or I don't know what, just be prepared that maybe tomorrow is your day, and tomorrow, it just needs to be scaling. So there's the tooling, right? If you want to scale, you need to be fast. You want to deliver stuff immediately. And then if there are more users, you also need a lot of data and analytics, right? So I think Dynatrace comes in place to pretty nicely. You have analytics. Also with the analytics from GraphCDN, you just know where you should scale up. And I think this is the main takeaway of GraphQL or from this talk.
I mean, one really good takeaway is, in my opinion, that if the next situation is where you have to argue if GraphQL or not, I guess you got now tons of arguments why yes. So it starts from the developer experience, heading up to like the speed and then to the scalability. So if anybody says GraphQL is slower or has worse performance than REST, I would call it a bullshit, to be honest.
Also because of the nicely quote, "Rest in peace," which I like the most.
Sorry for this kind of dead jokes.
Yeah.
Actually, what I
Alright,
wondered, you put a sheriff patch in it. Does the GraphQL or the GraphQL logo comes from it? Because
No,
it looks
it
exactly
just
the same.
matches up perfectly.
Okay.